How did Napoleon Bonaparte's carriages forever change how we measure time? In 1795, Abraham Louis Breguet, watchmaker to the court of Louis XVI and Marie Antoinette, set out to solve one of the most frustrating challenges in horology. Pocket watches did not keep time consistently. When held flat, they were precise. When held vertically, they lost accuracy. Gravity was the problem. As the balance spring shifted position, it disturbed the rhythm of the watch. Breguet's solution was revolutionary. He placed the balance wheel, spring, lever, and escapement inside a rotating cage, a mechanism that would continuously move, averaging out positional errors. He called it the Tourbillon. One of the few masters of the Ancien Régime to survive Maximilien Robespierre's reign of terror, Breguet later received the patronage of Napoleon in 1798. The invention, initially intended to improve marine chronometers, found an unexpected testing ground: Napoleon's carriages. Constant motion became the ultimate challenge to precision. The first tourbillon mechanism weighed nearly 90 kilograms. By 1805, Breguet had refined it into a pocket watch, designed to maintain accuracy even when held vertically. But one question remained: what happens when movement becomes unpredictable? When a carriage tilts or the terrain shifts? The problem was no longer position, but orientation in space. In 1860, Albert Potter proposed a tilted tourbillon for carriage clocks. In 1928, Walter Prendel refined this concept, introducing a 30-degree inclination and a 6-minute rotation cycle. Yet the human wrist proved even more complex than any road. It introduced constant multi-directional motion, which led to a new question: what if precision required not just rotation, but multiple axes? By the 1970s, Anthony Randall and Richard Good developed double and triple axis tourbillons for clocks. These would only reach wristwatches decades later. In 2004, 3 distinct interpretations emerged. Grubel-Forsey introduced a double tourbillon with cages set at a 30-degree angle, rotating in 1 and 4 minutes. At Jaeger-LeCoultre, engineer Eric Coudray created the Giro tourbillon, a double-axis mechanism weighing less than a gram. Only 20 pieces were ever produced. At the same time, Thomas Prescher developed a triple-axis tourbillon. Driven by conical gears, 2 axes complete a full rotation in 1 minute, while the third completes a rotation in 1 hour. Aesthetic ambition also reshaped the mechanism. In 1920, Alfred Hellwig introduced the flying tourbillon, removing the upper bridge to reveal the full spectacle of its motion. This visual liberation would later inspire multi-axis flying constructions. Innovation did not stop there. In 1993, Qiu Taiyu introduced the mystery tourbillon, reducing the visible mechanism to the balance wheel and escapement, creating the illusion of a floating movement. Mastering a tourbillon demands more than mechanical expertise. It requires an understanding of gravity, motion, and materials at an extreme level of precision. Even gemstones have historically played a role, used within movements to reduce friction and stabilize components. In 2008, Aaron Bexey introduced the Primus, a triple-axis tourbillon incorporating gemstones with rotations of 30 seconds, 2.5 minutes, and 12.5 minutes. Only 9 pieces were ever made. The pursuit of complexity reached new heights in 2025. Jacob & Co. introduced the Astronomia Revolution 4-axis tourbillon, a movement composed of 485 components, featuring a constant force mechanism and a fully rotating multi-axis system. Its axes complete rotations in as little as 15 to 60 seconds, a record in mechanical watchmaking. Only 18 pieces were produced. More than 2 centuries after its invention, fewer than 250 watchmakers are known to have mastered the tourbillon, a mechanism designed to counteract gravity by never remaining still, a reminder that true precision is achieved through motion.